All right, today we're going to be talking about Chapter 9, Lesson 5. This is Slope-Intercept Form. So when we are talking about slope-intercept form for an equation for a graph, what we're really going to be looking at here is y equals mx plus b. Now, each one of these variables or letters represents something. So, for example, the y, this is the output. The x represents the input. This m right here, this is the slope. And b represents the y-intercept. Generally, we write this as an ordered pair. Along the y-axis, the x value is always going to be 0. And then whatever b is goes in that spot. Now, if you recall, the slope, a couple different ways that we can write this. We could either write it as change in y divided by change in x, or the equation is y2 minus y1 divided by x2 minus x1. So whenever we're looking for the slope, we're always going to be looking for two ordered pairs along a line. So let's go ahead and look at some examples here. So it says example 1, state the slope and y-intercept of the graph of y equals 1/2 x plus 3. Remember, the slope-intercept equation is y equals mx plus b, where m is the slope, b is the intercept. So the slope is going to be 1/2, because 1/2 is in the exact same location that m is, which is the slope. So the slope is 1/2. The y-intercept is this number right here. So we're adding a 3. So our y-intercept would be at 0, 3. Let's look at another example. This one's going to be slightly different because this one is not written in slope-intercept form. But it says state the slope and y-intercept of the graph of negative 4x plus y equals negative 10. Now, I want it to look like this. Right now, this does not look like this. In slope-intercept form, you have y on one side and x on the other. This has both of them on the same side of the equal sign, which means I want to get rid of this over here on this side and move it to this side. Now, in order for me to move something from one side of an equal sign to the other, I have to do its opposite. So right now I have a negative 4x, so I'm going to add 4x to both sides. Creates a 0 pair. I have y equals 4x minus 10. Now this looks like that. The slope, where m is, there's a 4. So the slope is 4. The y-intercept, where b is a minus 10, which means that my y-intercept would be 0 and negative 10. All right, let's look at example 3 now. Now, instead of simply going to be looking for the slope and y-intercept, we are actually going to be using those numbers to graph an equation. So the slope and y-intercept, the slope is negative 3. The y-intercept is at 0, 9. So what I'm going to do is I'm going to plot this ordered pair. 0, 9 is going to be along the y-axis between 8 and 10. So right here. Now the slope, it says it's minus 3. We can rewrite this as negative 3 over 1. This is going to be a little bit more helpful because this means we go down 3 to the right 1. So every single time we have an ordered pair, to get to the next one, we go down 3 spaces and to the right 1 space. So let's look at that. Now, this graph, each line is worth 2. So to go down 3, I need to go down 1.5 spaces. So here's half a space and 1 full space. I now need to go to the right 1. And again, each one of the lines is worth 2. So I go halfway between. I'm going to do exactly the same thing again. Go down 1.5 to the right 1. And now I have 3 ordered pairs. I can connect those with a line, and I would have a graph that looks like this. And this equation is y equals negative 3x plus 9. What you could also do, if you're not quite comfortable with actually graphing from simply the equation, you can make a table. So what you could do is use 0, 1, and 2 for inputs. This is our function table, if you recall. So our first ordered pair will be at 0, 9, which is right here. If I use an input of 1, I now have negative 3 times 1 plus 9, which would be 6. So my next ordered pair will be at 1, 6, which is right here. Next one, again, I could use 2 as my input. So negative 3 times 2 is negative 6, plus 9 is 3. So I have 2 and 3 for my last ordered pair, which is right here. So either one you want to do. You can start at the y-intercept and use the slope to find the rest of the ordered pairs, which is what we did to find the graph originally. Or you can create a table that finds the exact same values. All right, let's look at one more example here. So it says a class spends $75 on ingredients and then sells cookies for $5 per dozen. The total amount earned for y for selling x dozen cookies can be represented by the equation y equals 5x minus 75. That's important. So graph the equation. So I'm going to simply use the slope and y-intercept to graph this. So the slope is 5. The y-intercept is 0, negative 75. So if I come to my graph here, 0, negative 75 is right here. I'm going to go every 10. The reason why is because if I use 10 for an input, each line, first of all, is worth 10. But if every 10 that I use, I go up 50 for my slope. So I'm going to go to the right 10, go up 50, so I'm now right here. Go to the right 10, go up 50 again. That's right here. Same thing, go to the right 10, go up 50, right here. And I can connect those all with a line. Next thing it says, letter B, it says describe what the y-intercept and the slope represents. So the slope represents cost per dozen cookie, or per dozen cookies, I guess. Because that's what it says here, $5 per dozen. The y-intercept represents the initial cost of ingredients. Which is right here. All right, so that's going to be the end of lesson 5. If you have any questions, please let me know.